Hello students, today we are going to look at Chapter 1, Section 3. We're actually going to split this section up into 2 different days, so we're only going to be doing a little bit today. Well, let's start off and talk a little bit about some measurements. SI is the units that we use to measure different things in the lab. SI stands for International System of Units. And scientists use the SI system so that they can interpret one's data. Because we speak so many different languages, we need to have one set so that we can understand data that's been given from Japan to England to Canada to the US. All of them need to make sense. There are some base units. If you look at there's a table on page 16 of your book that you can look at that has more, but here are 3 of them. Length. Length is a straight line distance between 2 points. M, or meter, is the SI unit for length, so meter. We will work a lot more with length in semester 2. Mass. Mass is the amount of matter in an object, and kg, or kilogram, is the SI unit. So kilogram is the SI unit. And volume. Volume is the amount of space taken up by an object. Meters cubed is the SI unit for volume, though in our class we'll often work with milliliters because we'll be working with liquids, whereas meters cubed is for solids. Measurements. Anytime we have a measurement either in the lab or if we're working with measurements in the class, it always needs to include a number and a unit. A unit comes after the number. You also need to include the estimated digit as well. The meniscus. The meniscus is this curved line whenever you are pouring into a graduated cylinder. And when you're reading, you want to make sure that you read at the bottom of the meniscus. And you want to make sure you include the estimated digit, and we'll be working with that all year long for the estimated digit. So looking at this graduated cylinder, you want to make sure you're reading at the bottom of the line. And I'm going to ask you, what is the volume of the water? You should pause and try to figure it out on your own. Looking at the volume, you can see it goes from 60 to 70, and it takes 10 lines to get up to 70. So that means this midpoint was 65, and so the bottom of the line is between 66 and 67. So you need to estimate how much in between 66 and 67 is. So I estimated it as 66.1 milliliters. You might have estimated it as 66.3 milliliters, and that would be okay because that last digit is an estimation. We add milliliters because we never use a graduated cylinder. You're working with liquids, which is generally in milliliters. Precision. Precision is a gauge of how exact a measurement is. For example, how long is the pencil? Let's say I ask 3 different students how long a pencil is. One student comes back and says the pencil is 5 centimeters. Another student comes back and says the pencil is 5.2 centimeters. And a third student comes back and says the pencil is 5.24 centimeters. Now, precision is how exact a measurement is. I want you to think and try to determine which one is the most precise. Well, the last answer is the most precise, because it uses the most digits past the decimal point. So however many digits past the decimal point, that tells you the precision. The more there are, the more precise you are. Accuracy. Accuracy is the closeness of a measurement to the actual value. So let's talk about how long the pencil again. We're going to assume that the pencil is 5.2 centimeters. I ask students again, and one person says that it's 5.8 centimeters. And another person says that it's 5.1 centimeters. Which person is more accurate? Well, the second answer is more accurate because it's closer to the actual value. So whichever one's the closest to the value is going to be more accurate. And that is actually it for notes today. We don't need to worry about temperature. So make sure you do the survey.